just want to show this line of code real quick. I forgot to explain it. This pass is basically a placeholder. It's kind of a way to reference code that's not actually created. It's just to allow the object or the code to be executed regardless of what's there. So think of it as a kind of placeholder. So you don't want to add or have any code there necessarily, but you're telling it to continue executing regardless of the code being potentially incomplete. It's actually not necessary, and so we could remove it, but I put it there as a kind of reference to myself earlier to sort of do the constructor and do other kinds of code. So we could just leave it there, but it's basically passed over, think of it that way, by the code when it's executing. Okay, so let's go to this module called load data. Load data is basically going to do a lot of our key functionalities. You can see that it's importing two kinds of system libraries, CSV and OS. So these are coming from Python itself. They are already built into Python, but I'm referencing because I will use them. So to do that, I reference these libraries from CSV and OS. They were using CSV as a type of file system, CSV files, comma separated value files. So there are libraries in which those files can be accessed and utilized. So in object-oriented programming, oftentimes we use libraries, built-in or otherwise, potentially coming from other people's code, that allows us to sort of expand our functionality. This is very important for us, and we'll be utilizing this a lot in our class. OS is another built-in library, the operating system, and so we'll talk about that in a moment, or show those in a moment. I'm also utilizing code that I've built. And once again, to utilize this, you can use the from statement and import statement. So from is basically, remember, referencing the actual sort of module. So the module in this case is another folder called data. So now I'm in the loading folder. So to reference the data folder, I have to specify data, and dot references the actual module in that folder. So child data, you can see the module child data here. And then to get the actual object is I have to go use the from statement. So the object is here. You can see child data. It's in the child data module. So it's being accessed. Notice that the object has capital, is uppercase in this case. Same thing. There's another module I've created I haven't discussed yet. It's called data analysis, and I'm accessing it the same way. And I'll show you what data analysis contains later on. I'll be using it in this example. So now I'm creating a class called load data. You can see the comments that explain what exactly load data is about. Basically, it loads data. And it has an init method, an initialization, a constructor basically, that will take the input's file location. This is a string value that references the location of a file, as you can see in the comments. And I'm going to do is run a method called run file. So I define it as a method. It's called run file. It has just itself as the input, or basically no input really. And so that will be the method. There's nothing that's going to happen in terms of the input. The first thing that will be executed is this open method. Open is actually a built-in method within Python. You don't even need to reference any libraries. If we go real quick to this page in the python.org website, you can see Python has a number of built-in methods, and one of them is open. You can click on it, see what it actually does to explain it, and it explains to you the keywords, so R for read types files, for instance, and so on and so forth. So I'm basically reading a file by saying open and telling it to using this R and T even is fine, RT sort of keyword. So what I'm saying is this file location, this input called file location, which is a string for a location of a file, I want it to be opened, and it will create this variable called f. So open will open essentially a file. And you can see I've created this try clause. Try clauses are basically ways in which you tell Python you want to execute a block of code. You can sometimes add catch or other kinds of keywords such as finally to basically tell other potential clauses of code or code blocks to be executed if the try clause fails. So try clause is a way to sort of execute a block of code. You don't need it, but it's a good way to sort of look at potential errors that may arise. It's a good way to sort of isolate some key code in a related functionality. So the related functionality in this case is opening a file and reading through that file data. So from the actual file, in this case, a file I've called data file, which is located in the data folder. So what I did is I created a folder called data. I've put it into my Hello World project. and this will be now referenced, and I'll show you that as we go along. So what I'm doing is now using CSV. Remember, CSV was referenced by this import statement, so now I can see what's in CSV. So just simply hovering over CSV gives me a sense of what's there. This is something that allows us capability that comes from PyDev. You can see I can even click on it to get more information on what's in CSV, so I can actually go into CSV and look at its functionality. It's not necessary here. All I really care about is that CSV allows me to read over the file. So I look at the methods in CSV. You can also do this, press the dot, and it shows you the methods that are in there. So one of them is read. And so what you can do then is simply add this input f, the file itself that's been opened, into this reader. So what should happen is the comma separated values are read, and it returns a value called reader in this case. So what I'm calling reader. So I will then, of course, access it in a moment in terms of the value. So reader contains the values that are coming from the comma separated value. So I created the variable called I, and so now I'll iterate over that variable. So remember, this is I'm creating a row variable that's within this reader. So reader is now essentially, think of it as an array of input. So the first line is going to be the title lines in this input. So if I open data file real quick, just to show you what it looks like, you can see it has two lines. One line is the XYZ, the sort of titles of the data. Second line is the actual data, and then so on and so forth if I added more and more lines. And so it's going to sort of iterate over it. I'm telling it to skip the first line because I don't really care about the title line. But what I'll do is after I does not equal 0, it'll execute this block of code. So you'll see is that it'll get this float value it's going to create, or it's going to create to the input as a float value. So 1 will be the first input, so it'll be 1.0, and then so on and so forth. And these variables will be then sent into child data. So remember, child data takes 3 inputs. And so that'll be added to the child data. I'm creating a variable within this object called CD, which is, of course, child data. So child data is local creation instantiation of an object, and that object is being referenced by the CD variable. So once again, Python allows us to create basically any kind of data type, an object, a float, an integer, it doesn't really matter, and we can reference it by simply creating it, the self dot and then the name of the variable that we create as a way to reference that variable. We will then have access to that variable later on. So finally is a kind of way to execute code regardless of what happens in the try code. So it's a final kind of execution, think of it that way. It's something that has to happen at the end of the clauses that we set up. So try is a block of code that executes and finally closes. This basically tells it to close the file stream. So when we open the file system, we did the open, we opened the file stream, that is access to the file, but we have to then close it so that it's released essentially back into the system. So this kind of makes it helpful for the code to execute, so we're not kind of opening a file consistently even after the execution of the code. So that's all this really this object does. A lot of the rest of this stuff is referencing other kinds of executions that we'll talk about